Now we move on to the next topic, that is essentials of a chemical equations. Essentials of a chemical equations. First thing, that is it should be balanced. Any chemical equation, it should be balanced. It means that the number of atoms of different elements on the two sides of the equation must be equal. The number of atoms of different elements on the two sides of the equation must be equal. Number two, it should be molecular. It should be molecular. Any reaction you see here, molecules are represented here, no atomic reaction is here, it should be molecular. Third one, it should represent an actual chemical change. It should represent an actual chemical change. These are the three terms which are very essential for a chemical equation. First is it should be balanced, it should be molecular, should be actual. Now, to make chemical equation more informative, how to make chemical equations more informative. More informative means how should we know the change, physical change, or the physical state, or the heat changes, or the conditions under which the reaction takes place. How to make chemical reactions more informative? It must be done in three ways. First way is write about physical state. Physical state. Second thing, we must know about the heat change. About the heat change by writing the symbol delta or the heat on either side of the reaction. Third one is the condition under which the chemical reaction is taking place. First of all, the first one we will discuss here, to indicate the physical state. To indicate the physical state of reactants and products. To indicate the physical state, we write small s for solid, small l for liquid, small g for gaseous, aq for aqueous solution, upward arrow for gaseous products, and downward arrow for insoluble products. Insoluble products, that is also called precipitates. Precipitates. This is the first way. For example, We take zinc, it is a solid, we write S. We take H2SO4, that is aqueous, we write here aqueous. Product formed zinc sulfate, again aqueous, and the gas formed hydrogen, written like this, arrow, upward arrow. One more example, silver nitrate, aqueous plus sodium chloride, aqueous gives AgCl, that is silver chloride. Solid, again it is a precipitate, white precipitate, plus sodium nitrate, NaNO3, again aqueous. Number 2, we write indicate the heat changes. How to indicate the heat change? Heat changes, which is also called thermochemical equation. Heat change where the heat involves is also called thermochemical equations. What are thermochemical equations? Chemical equations representing the heat evolved or absorbed during the reaction are called thermochemical equations. Example, first a exothermic, that is heat evolved. Example, C solid plus O2 gaseous gives CO2 gaseous plus heat is given out in this reaction. CaO, that is quicklime solid, plus water, that is liquid, gives CaOH twice, plus heat can also be written like this, that is delta, known as delta. After this, heat absorbed, B, heat absorbed, this is also called exothermic reaction. You can write exothermic reaction. Heat absorbed, endothermic reactions. In this case, heat is being taken. For example, nitrogen gaseous when reacts with oxygen gaseous, it wants heat energy for the reaction. We write like this here, gives nitric oxide, that is gaseous. One more example we can take here, barium hydroxide plus ammonium chloride, barium hydroxide plus ammonium chloride plus heat gives barium chloride plus ammonium hydroxide. Okay. Now the third way to represent this is to indicate the condition. Third way to indicate the conditions under which the reaction is taking place. Condition under which the reaction takes place, that is temperature, pressure, catalyst, if any. These are the condition: pressure, temperature, catalyst. These are the conditions. For example, here we will take again the reaction: nitrogen when reacts with hydrogen, it takes place at 500 degrees Celsius temperature and at 200 atm pressure in the presence of iron catalyst. This iron acts as catalyst. This is atmospheric pressure and this one is temperature. These are the conditions in which under which this reaction takes place and forms ammonia. One more reaction I am going to take here: potassium chlorate. It is solid. When it is heated in the presence of the catalyst MnO2, it gives twice KCl solid plus 3 O2, that is again gaseous. This is